Hello students, let us discuss 12 behavior of matter, that is de Broglie relationship in this video. In 1924, de Broglie suggested that just as light exhibit wave and particle properties, similarly all the microscopic particles also exhibit dual character. So, de Broglie proposed that as the light exhibit both wave-like and particle-like properties, matter too exhibit wave-like and particle properties. On the basis of these observations, he derived a relationship between wavelength and momentum of matter. That relationship is called as de Broglie relationship. So, he has observed the dual nature of matter. Let an electron revolving around the nucleus, in which the radius of the orbit is taken as r, lambda is the wavelength, m is the mass of the electron, and c is the velocity of the electron with which it is moving. So according to the Planck, E is equal to h nu, where nu is equal to c by lambda. But according to the Einstein, E is equal to mc square. So when you combine these two equations, you will be getting a relation, that is de Broglie relation. Lambda is equal to h upon mc, where m into c, that is mass into velocity, that is mass of electron and velocity of electron, m into c is equal to momentum, that is p. So we got an equation, that is de Broglie relation. Lambda is equal to h by p, or we can say the lambda is equal to h by mc. So de Broglie has given a relation between the wavelength and the velocity of the electron, which is revolving around the nucleus in a circular path but in the wave form. So this relation is called as a de Broglie equation, that is lambda is equal to h by mv, where lambda is the wavelength in meters, v is the velocity in meters per second, m is the mass in kilograms, h is the Planck's constant. So, according to de Broglie, every object in motion has a wave nature, because each and every object is matter. So de Broglie focused that all matter have dual nature, that is particle as well as wave nature. So according to de Broglie, every object, whichever is in the motion, have a wave nature. Do you find a wave nature in moving ball? But the wavelength associated with ordinary objects are so short because of their large masses, as the de Broglie equation is lambda is equal to h by mv. So when you find the relation here, the wavelength and the mass have inverse relation. That means greater the mass of an object, lesser will be the wavelength. So from this equation it is clear that the wave nature is not much observed in the case of large objects, but it is clearly observed in the case of smaller particles, or we can say microscopic particles. So according to de Broglie, every object in motion has a wave nature, but the wavelength associated with ordinary object are so short because of their large mass. Therefore, their wave properties cannot be detected. It means that the wave nature for large object means the object which have greater mass cannot be detected, or we can say that the wave properties are not observed because of their large mass, because of they having very short wavelength. But about in the case of microscopic particles, the wavelength associated with microscopic particles like electrons, protons, and other microscopic particles which have very small mass, for them the wavelength can be detected experimentally, because lambda is equal to h upon mv. That means smaller the mass, greater will be the lambda. So according to de Broglie relation, every object in motion has a wave nature. Even we are also a matter, we also have wave nature, but because of large mass, the wavelength associated will not be detected. So this can be easily detected for the case of microscopic particles, as electron are also a microscopic particle. Therefore, from this, he concluded that the electrons revolving around the nucleus have a wave nature as well as the particle nature. So, de Broglie relation played a very important role in formulating the modern concept of structure of atom, that is quantum mechanical model. So, the problem related to de Broglie relation will be discussed in the next video. Thank you everyone.